Bye-bye.
Hello, Mr. Henry, Mr. Ryan, right? Okay.
Nice.
Okay, so do you still remember GCD? We talked about that 2 days ago.
Of course
GCD.
we did.
What's that? What does it mean?
Greatest common divisor, blah, blah, blah.
Greatest common divisor. Okay,
Blah,
good.
blah.
So, 24 and 16, what's the greatest common divisor?
Is it 4?
No, it's 4 is divisible.
8.
8, yes. How do we do it? Look, 24 divided by 16, remaining 8, right? So we move this. 16a. 16 divided by 8, remaining 0. When it's remaining 0, this is the greatest common divisor. 24 and 32, what's the greatest common divisor?
Is it 8?
8, yes. How do you do it? 24 divided by 32, remaining 24. Move it here, shift it. 32, 24. So basically, when A is smaller than B, we just swap it around. 32 divided by 24, remaining 8, right? Look, 24A. 24 divided by A, remaining 0. What is remaining 0? This is 8, okay? This is the way we calculate the greatest common divisor. And do you still remember this? LCM. Least common multiples, okay? What's the least common multiple of 16 and 24?
24 times 2.
So you basically...
192?
No.
A million.
No, look, 32,
144?
48,
A million.
what? 48.
6 billion.
Am I right? So it's 48, am I right? 48 is the count. How do we get it 48? So 16 times 24 divided by the greatest common divisor of both.
Which
16.
is 2.
This is 8, right? So look. So it's 16 times 24 divided by 8. So that's 48. That's how we get the least common multiple. So basically, least common multiple of two numbers, A, B, can be calculated as A times B divided by GCD A, B, right? So while B is not equal to 0, A, B equals B, A modulus B, okay? And then return A, okay? This can be done in recursion. So define GCD AB. If B return GCD B A modulus B, otherwise return A. Okay. So that's the recursion. That's the iterative. Coming back to today's problem. So we're given an array. Right? Array. We want to find out the minimum split of these numbers. So we want to split the numbers into continuous groups, subarray. We talk about subarray and sublist, right? Subarray and sublist are continuous. Subsequent is not continuous, right? Subarrays are continuous. So we want to split the array into subarrays. Each number belongs to one subarray only. And then each group, the GCD, the greatest common divisor of all of it, is more than 1. If two numbers, the GCD A and B, if it equal 1, right? For example, like 3 and 7, the GCD of 3 and 7 is 1. Then we can say that 3 and 7 are coprime. Yeah, coprime, because their greatest common divisor is 1. Okay. So coming back to this question, so we want to find out the mean split of subarrays, so that the greatest common divisor of the numbers in each group is more than 1. 12, 6, 3. What's the greatest common divisor of these? 3. Yeah, 3. It's more than 1. What's the common divisor of these? 2. Right? So yeah, bigger than 1. If 14 in the first group, what's the greatest common divisor of these 4 numbers? 1, yeah? So it does not satisfy the requirement. Alright, so we want to find out the minimum split. The subarray is continuous, so we can do this greedily, right? What's the idea? What's the idea we can apply the greedy diagram? If we can include the next number in the subarray, we include it, right? Bless you, right? Bless you again, okay? So look, 12, we can do this, look, 12, greatest common divisor, 12, right? 12 and 6, greatest common divisor, which is 6, alright? It's still bigger than 1. 3, greatest common divisor is 3. So look, when we are at 12 and 6, the next number is 3, alright? But including the next number, our greatest common divisor of current group is still bigger than 1, still meets the requirements. So we can just take it. alright? Because when we take it, it does not compromise the global, the optimal solution, because we are looking for the minimum split. If we can include the next number in the current group, we do not compromise the global optimal. Does it make sense? Yeah, because we are looking for the minimum split. Minimum split, what does it mean, minimum split? So we want to include as many numbers as possible in the current group. Make sense? Let me repeat. So this is the greedy. So we want to find out the minimum split, right? So we want to minimum split. That means that we want to have as many numbers as possible in the current group, as long as it does satisfy the requirement. Right? So look, 12 and 6. My current group is 12 and 6. So by including the next number, which brings the GCD to 3, it still good. So we want to take it, right? Am I right? It's better we take it. If we not take it, we leave it to the next group. Things may get worse. Am I right? That's greedy, okay? What's greedy? Greedy strategy is that you always make a decision and in the best of your interest at the current point. Right? You have a bananas, 10 bananas. You can have 6 bananas now and 4 later, or you can have 4 bananas now or 6 later. On the greedy strategy, you always pick the best strategy at your point, which is 6, right? Ryan, you pick 6 now. That's greedy. Define mean split. Okay, so at the beginning, answer equals 0. Current GCD, let's set it to 1. Okay, we can go through the numbers, right? Enumerate. What does it mean? Enumerate.
It means like you order them like keys and
values. So for example, like A, B, C. Okay, if we enumerate it, it will become 0, A. That's a tuple, and 1, B, 2, C. Okay, so the key is here. This is a tuple. Okay, actually it's not keys. It's the first element in the tuple. Is the index. The second value in the tuple is the actual value. Okay, so we go through I, J in enumerate array. Okay, or array. Right. So now we have to check. We have to apply the current. Current equals GCD current and J, right? And if the GCD is 1, if the GCD is 1 means that this number needs to be in the next group, not this group, because the greatest common divisor of all the numbers up to now, this group is 1, so we can't include this number at index I, right? So we have to increment the answer. We need one more group, one more split, and the current we need to set it to this new number J here, right? And then at the end we do 10 answer. 12, 6, 3, and then 14, 7, right? This was the example, okay? So look, answer equals 0, and GCD equals 1. The current equals 1. 12, look, 1 and 12, GCD is 1, so we need to increment the answer. And GCD is set to 12, the current set to 12. 12 and 6, the greatest common divisor becomes 6. Right? Become 6 is not equals 1, then we continue. 6 and 3, the greatest common divisor becomes 3. It's still bigger than 1, okay? Now 3 and 14, look, greatest common divisor becomes 1, right? Becomes 1, so what happened? We plus 1 here, answer plus 1, right? And then we set the greatest common divisor here to 14, right? 14, the next number, 14 and 7, greatest common divisor is 7, right? And it's bigger than 1, so we don't increment, the answer is 2, so we split it here. Make sense? Yeah. What's the time complexity? That's a good guess. This is ON obviously, but here, here GCD. We talk about GCD. The complexity of GCD AB is log the minimum of AB. Okay. Okay. So this is kind of that we have to take it into consideration that ON times GCD least ON times log n. Maybe ON times log n, okay? Okay. This is the upper bound, okay? In practice speaking, yeah, the time complexity, this is very fast, okay?
So we have these numbers.
Yeah.
And we go split them into groups. And
yes. And the requirement of each group is
the greatest common divisor of them is must be strictly greater than 1.
What's the keyword today? What's the strategy?
Greedy.
Greedy, yes. We saw, yeah, okay. So how do we interpret this greedy thing? So if the next number,
Bananas.
yeah, if the next number, we can include it in the current group, we might just take it. Okay, well, space complexity is a one constant, right? A one constant. Greedy strategy is very popular. It's one of the classic algorithm in computer science. So it means that you always
Best
choose,
choice.
yeah, best choice at that point. You don't consider somehow in the future. There are 6 bananas and 4 bananas in front of you. You don't care what happened next. You just pick the best at that point. That's greedy, okay?
Yeah.
Okay, that's it for today. Bye bye.
Bye.